is we'll add, we'll take in to C, the contents of in to C, then increment in by 1. This is post index addressing mode. So C gets the first character. Now for the first time, for the first execution of this, there will be a stall. We can't avoid this, but furthermore, the forthcoming loops will not have this stall, right? Now, so after first time we loaded first character C, then we do this subtraction of suppose we took character K, which is 75. Now 75 and uppercase A is 65. 75 minus 65 T, 10, then is stored in T. Now T is the temporary register, okay, that is R3. Okay, now this T is compared with Z minus A, that is the difference, that is 32. Okay, this, sorry, 26. Z, uppercase Z minus lowercase z. Uppercase Z is 97, I believe, minus lowercase a, uppercase A is 65. Okay, so this gives difference of 26, means we are just comparing that is T, this 10 is within the range of 26, because uppercase characters from uppercase to lowercase z, uppercase to lowercase 26 only. I mean, so if this T is compared with 26, now here see this add ls stand for this conditional instruction, conditional execution, add with the condition. Add ls means add if less than. If T is not less than this instruction will never get executed. Okay, that is conditional execution for you. So add ls means if less than, after comparing T with Z minus Z is 26 and 10, if 10 is less than 26, then this add will happen, otherwise it will not. Okay, so if now currently T is 10, 26, this T is less than 20, so this is sure for true. Now this add will happen. What will happen here? A minus lowercase a minus uppercase a, that is uppercase is 65 and lowercase is 97. So 97 minus 65, sorry, yeah, no. So that difference will be added. That is 32. Sorry, this is 32 added with C, and C is stored back into C. That is uppercase A, uppercase K becomes lowercase k. So uppercase 75, lowercase 107. So 75 plus 32 gives us 107. So 75 plus 32, 107. So C becomes lowercase k now. So this is conversion happened. Now that converted character C we store into address pointed by out, which is out is nothing but register R0. So R0 points to location where we storing the converted string, and later out is incremented by 1. This is post index addressing mode. So out incremented by 1 later after storing the contents of C into address of out we stored. Okay, so this is string store byte. Next there is the instance called text test for equality. TEQ stands for test for equality of C and 0. If C is equal to 0, then if this is true, then it will come here. So LDR NEB, it will compare C and test if C is equal to 0. If C is equal to 0, it will come here. Now LDR NEB, load not equal, right? So LDR, this is again the conditional instruction here, a conditional execution of load. This load will happen only if this previous condition is not equal to. If after testing, if they are not equal, if C is not equal to 0, LDR is not equal, only then C, the contents of in is stored into C, and after incrementing by 1. We already incremented in by 1 here, so in is pointing to second character is stored into load into C, which is R2, only if previous test if equal is not equal to 0. Okay, then in is increment by 1. So this happen only when this test equality is not equal to 0, if they are not equal. Okay, now if they are not equal, then it will happen after this branch if not equal. The previous instruction is if they are not equal, branch if not equal, go to loop, then otherwise it will go to return to previous one. This CLR is loaded into PC gets a new address of the called program, it will return to the main program or which is called from. Now otherwise this will repeat. n number of characters to convert from upper to lower. So we have to observe this LDR NEB, very important instruction, and even LDR add ls. Now if you see here, now because in the previous example there was always a dependence between LDR and sub, because here LDR is happening here and there is, after that is a branch. Okay, there's no dependence between LDR and a branch here. Okay, that is how the optimization happens. LDR NEB and BNE, there is no dependence here. If this is true, it comes, otherwise it will not come here only. So there is no dependence between LDR and sub now, because there is an instruction between them called as BNE. So there is no dependency. BNE comes in between this sub and LDR, and so there is no dependency. Because of this, we'll be will be cutting down 2 extra clock cycles that is happening in the previous program. So every loop will be increased by 2 clock cycles, not for the first time but rather for the second time. So 2 clock cycles, number of clock cycles will be reduced by this, so which enhances the program speed almost 2 clock cycles into number of characters here. If the number is 10, then 20 clock cycles are consumed less here compared to the previous program. That's how optimization happens by preloading. Preloading means load happens before or at the end of the previous, the end of load happens, preloading happens at the end of the previous. This is the current branch, means current loop, previous loop's end, that is required provided at the end of the previous loop. So this is previous end of the previous loop, so this is current loop, so loading happens at the end of the previous loop, so this is new loop. So that's what the name indicates, preloading. Okay, so this is one of the optimization method of scheduling. Okay, so the schedule code is one instruction lengthy than the original, but saves 2 clock cycles per loop, which reduces the loop from 11 clock cycles. If you calculate those number of clocks, will be 11 in regular code, 11 clock cycles per character to 9 clock cycles per character, because this 11 minus 9, 2 clock cycles, because only because of those preloaded what do you call instruction, because loaded memory is loaded before branch happens. Okay, and load happens at the end of the previous loop instead of current loop's beginning. So that's how 2 less clock cycles are consumed here. So giving 1.22 times speed enhancement. This 9 by 11 gives you 1.22 times speed enhancement. That is very fantastic. 25% of enhancement, which is very good. So for a small size program of this sort, if you can achieve 1.2 times optimization, it's very good. Okay, so we'll see. And to observe is LDR NAB. Okay, have to observe this, because how does it work, it's very important. And we'll see how to schedule unrolling in the next class. So that's end of this session. We'll discuss the unrolling in the next class. Okay, so bye.